When people think of computers and IT security, what probably isn't the first thing they think of is industrial control systems. What we're really talking about here are specialized computers used in a variety of different types of industries. We're talking about things like manufacturing or water treatment plants or power grid utilities. So let's talk about this in a bit more detail because there are some serious security ramifications related to these. The first thing we have to figure out is what a programmable logic controller or a PLC is. So a PLC is an industrial control system or an ICS device. It's on the network, it has an IP address, it has a bunch of ports that you can physically plug things into. Things like sensors, maybe to determine how much pressure is in a pipe, or maybe a valve in a water treatment plant to see how open it is. Or maybe you are plugging in robotic machinery that's used on an assembly line. Maybe you've got actuators which are used to actually move things around physically in an industrial environment. All of those types of things can be connected to a PLC. So we know it's got an IP address, therefore it's on the network. So what does that mean? It means it's a potential attack vector. It's a computer that's on a network. But what's scary is that it has a connection to something that actually moves in the real physical world. Now, there are many different companies that create PLCs and have for decades. This is not a new technology. Companies like Siemens, Allen Bradley. So what do we need to think about for security? Well, we already know it's a network device. We should harden it. But how do we harden these things? The first is to apply firmware updates. But if you think about the nature of a PLC in an industrial control system, let's say it is controlling robotic machinery on an assembly line in a car manufacturing plant. Okay, so then the PLC will be physically connected to that equipment, and then there needs to be a monitoring station that monitors to make sure that that equipment is working correctly, collects statistics, like how long it takes for certain operations to go by and so on. The point is this, that monitoring station is only running a regular operating system, like Windows. So we need to make sure that that side of the equation is secured, the way we've already talked about hardening Windows. Because if that machine is vulnerable and malware can be infected on that device, then it could skew the readings from the PLC. And that's exactly what happened with the Stuxnet worm in Iran. So the idea being that we need to secure the network, the PLCs, and the stations, the monitoring stations that retrieve data from the PLCs. A real-time operating system, or an RTOS, is what is used with the PLC. So you're not going to have a PLC that has an embedded operating system running Windows, at least not often, certainly not that I've run into or heard of. So we have lightweight, function-specific operating systems that are embedded into the PLC firmware. They are designed to be very reliable and very quick, and they are specialized to do things like control valves and sensors and robotic machinery. Now, examples of these types of lightweight PLC operating systems would include RT Linux and VxWorks. So these are designed specifically for PLCs. So again, we need to make sure we apply firmware updates. If there's a vulnerability in RT Linux, for example, on a PLC, then we need to make sure we apply that firmware update that might address that security problem. The other thing is network isolation. Do we really want our PLCs, which have IP addresses, on a network that's actually connected to the internet? Does that really make sense, like for a power plant, for an oil refinery, for a water treatment plant, and so on? The answer obviously is no, it doesn't make sense. It doesn't mean it can't be infiltrated. The best way to break into something is to trick people. That's what happened with Stuxnet, again in Iran, when they were trying to enrich uranium. The idea being that if someone can be tricked into clicking a link or bringing a USB thumb drive or a computer into a network where that computer or thumb drive is infected, even if you connect to a network that isn't physically connected to any other networks, you can infect it in that indirect manner. So we have to think about these things when it comes to industrial control environments. Now, another term you need to be aware of is supervisory control and data acquisition. Some people pronounce this SCADA, other people will pronounce it SCADA. It doesn't matter as long as you know what it is and the role it plays in an industrial control environment. So what SCADA really is a collection of industrial control system devices that are focused on specific tasks. like we've talked about, manufacturing, water, oil pipelines, power grid. Now, the idea with SCADA is it can also be dispersed over a wide area network. So you can imagine in a certain part of the world where you might have power plants in different areas that serve different cities. But those might be under singular control, and that would be supervisory control and data acquisition. That's the term we use to refer to that collection of locations with PLCs as a single manageable unit. Now, pictured on the screen, we have an example of what the general network flow would look like. On the left, we have our SCADA master station. As we've mentioned, that is a station that would have access to retrieve statistics from numerous PLCs. How many cars are we producing on the assembly line within 1 hour? Is everything working correctly? Do we have the right amount of pressure in this pipe? That kind of thing. Now, often, remember with SCADA, we've got this happening over a wide area network. It could be geographically dispersed. And so we might have a WAN link from the SCADA master system that connects to what's called a remote terminal unit, RTU, which in turn allows access to the PLCs, the programmable logic controllers, in that remote location. So if this feels like terminology soup, it is, but that's going to be an important part for the Security Plus exam. You might be indirectly tested on your knowledge of what role each of these items plays.